Welcome, folks, to the last video of the chapter. This is chapter 2, section 9, solving absolute value equations and inequalities by graphing. And it's a one-pager. It's a shorter video, so yes, all right, you made it. And I think you earned it also after that last video. Whew, I think that was like 25 minutes long. Sorry, I'm gonna try not to do that to y'all, but sometimes we just gotta. Big ideas: split the equation or the inequality into two functions to graph, and then interpret those intersections or the x-intercepts. Let me show you what I mean. If you're looking to solve this, we've got techniques to solve this. You know how to do it. You undo the multiplication, you undo the absolute values, you undo the addition. But if you wanted to, you could also check out the inspire. Graphically, what you can do is you can take the left-hand side and put it as the blue function 1, and the right-hand side and put it as the blue function 2, the red function 2. And now the intersections become incredibly important. You all know the relationship between intersections and solutions. And so you can see here, the intersection here is at -9 and the intersection here is at 3. And so that there's the x values that both produce a y value, an output of 42. You put -9 in here and you get positive 42. You put -9 into the red function. Also, you still get an output of 42 because the output's always 42. Same thing here. Input 3, output 42 for the blue function and the red function at the same time. So you can express the solution set like this. There's two solutions in curly brackets, -9 and also positive 3. Let's move on. Oh, look at this. We've got an inequality now. We've got an absolute value less than 42. And we know how to do that. We know this is going to be you have to figure out if it's case 1 or case 2. And I'm thinking it looks like case 1, like this. Boom. But instead of using the techniques by hand, let's actually use the inspire, some technology to check out what that looks like. So here you can see the absolute value goes into the blue function 1, and the 42 goes into the red function 2. Graphing these, what we really have to figure out is when is function 1 less than function 2? Like, when is it actually physically lower on the screen when is the blue function physically lower on the screen than the red function? And you can see the red function here, the straight line, is at 42, and all of these points have y values that are less than the 42, where the red function is. So actually, it's not just one point. It's a long interval right here of x values that will actually make it less than 42. And they start at -12 and they go up to 16. But I don't think we should include -12 and 16 because of the less than symbol right here. So it's an interval. It starts at -12. It goes up to 6. This is, by the way, this is not a location on the graph. This is not an x value, y value. This is an interval of collection of x values. It starts at -12. It goes up to 16, and does not include -12 and does not include 16 because all these x values produce y values less than 42, lower than the red line. Now you can write it as interval notation, or you can write it as an inequality notation, and I think that if you're paying attention, you can check out and you can see what would be underneath the red dot. It goes from -12 less than x less than all right, 3, example 3. Now we're going to only graph. Maybe it's simpler to graph just one function. Take this absolute value thing and put it all in, and because when is it going to be less than or equal to 0? And we don't need to graph the red function 2 of 0 because we can just use the x-axis. We know that the y value is 0 along the x-axis. So what we really want to do is we want to find where the x-intercept is. And we want to figure out when is it less than or equal to 0. Well, you can see here, this is where it's plotted, and it intersects the x-axis right here. And there's only one number that allows the blue function to be less than or equal to the x-axis, and it's right here. It's actually -1.5, and there it is. And if you think about it, that kind of makes sense because this absolute value is only going to produce, at best, it's never going to produce a negative number. So when is this? So if it's not going to produce a negative number, the only value that could make this less than or equal to 0 is 0. This has got to be equal to 0. And you can see right here, the question is kind of like, so when is the blue function lower than or equal to the x-axis? Well, it's never never lower than. At best, it's only equal to. So there's only one number that satisfies this inequality. The number that makes the blue function just barely touch the x-axis, and then that's it. It's just negative 1.5. Let's see. I think that's all I wanted to say here. Let's jump over to the Inspire. Whew. All right. So you can see here, only a minute and a half. You guys, oh, you're getting out lucky today. All right. So the Inspire, how would you do that here? Follow along, folks. Here we go. We're going to go to the the Graphing the Scratchpad and type in 2 times frequently used symbols, and then select the absolute value that's all the way on the right, top right, and then x minus 3, not negative 3, x minus 3, and then close the absolute value, or get out of the absolute value and say minus 1. And there it is. Oh, check that out. We've got a nice little v, absolute value v on the graph. I'm going to go tab 3 to graph the second function, f2 of 3. I'm going to go to the menu, and I'm going to analyze the graph. I want to find an intersection, and that's for intersection. Enter. All right, now it needs to know the lower bound. It can't just look at the entire thing. I don't know why it can't, but it needs you to just kind of give it an interval. We're going to go between there and just a little bit further there, and now it can find it. It's getting super crowded. I'm going to drag the function name over a little bit. So the intersection is 1, 3, and then you can go menu, trace, and analyze graph, and there's a lower bound, upper bound. Intersection is 5, 3. And there it is. All right, folks, have a great day. I'll see you in class. I hope you enjoyed the short video. I did too. Take care.